everybody can still hear me. So I will be talking about EESSI, the European Environment for Scientific Software Installations. It's in some ways similar to a central software stack. It also uses modules. So EESSI in a nutshell is a broad range of scientific software that is available and doesn't compromise on performance and will run on your laptop, on an HPC cluster, in the cloud. So I will tell some more. So it's a shared repository of optimized scientific software installation. It was, the idea came from a need to avoid duplicating the work. So as Kenneth said earlier, is when we install new software, we have to install it for the different CPU targets, but this is not only done at UGent, but it's also done at VUB, on other sites at EESSI, but also through Europe and throughout the whole world. So that means that each HPC site does a lot of the installation work and needs to do it over and over again. And so this is EESSI as a way to provide a uniform software to the users, regardless of which system they're running on. It should run on any Linux OS system architecture. So if you have Linux on your laptop, you can use it. It focuses on performance, automation, testing, and collaboration. The development of EESSI at the moment is funded through the multi-xScale Euro HPC Center of Excellence. The major goals of EESSI are, providing a uniform software stack without sacrificing performance for mobility of compute, like for instance you have with Conda or containers. So avoiding duplicate work for researchers. So for instance, if you're working on multiple HPC systems where EESSI is already available, it might be more interesting for you to get your software available in EESSI rather than having to contact each different HPC sites so that they always have to do it over again. It's also handy for HPC training because you don't have to spend a lot of time trying to get the software installed on all the participants in your trainings, but you can just install one tool, which I will go into later, and everybody should have the software that you are using in the training. So this is like a general overview of how EESSI is. So it's a file. So you first have a file system layer, which is installed through CERN VMFS, and that's also the only tool you need to install to have EESSI available. You do need root access, so if it's not yet on an HPC system, you will have to contact the help desk of the HPC system and ask them if they're willing to install CERN VMFS and make EESSI available there. Then you have a compatibility layer, and this makes sure that it works on any Linux distribution. So instead of linking the libraries of the installed software to the host operating system, it's linked to the compatibility layer, which then makes sure it works on any. And then you also have the software layer in which you have all the optimized applications and dependencies. For GPUs, we have to do some tinkering, so that's what the gray box is about. But we'll not go too deep in that. And then, as I said, we also want to focus on testing. So we have our own test suite developed with Reframe, which is also portable. So with like one configuration file, you can get setup testing for EESSI software on your system. So the EESSI ingredients, I've gone through them already. So we're using Gentoo Linux for the compatibility layer, CERN VMFS for the file system layer. For the software layer, we're at the moment only installing with EasyBuild, but we're also looking at tools like Spec to use as well. Then, as I said, we're also using LMOD and the module system to make the software available. And we're using Arch Detect to make sure that the user doesn't have to know on what kind of system they are, but EESSI will set up everything so that the right paths are set up on your system and that the most optimized software that is available in EESSI will be used on your system. So a general overview how EESSI looks is on the left side of the slide, you have different applications who are installed into EESSI, and then it can be, and then it will be available momentarily. Yeah, and it takes a few minutes if new software is installed for it to become available on other sites. But yeah, once it's in the application is installed at EESSI, it will become available in HPC clusters, in the cloud, or your personal laptop. So how does EESSI work? So it's automatically streamed in on demand via CERN VMFS. I will show some, we'll show something later about that as well. It's built independent of the host operating system, so it doesn't matter on which kind of Linux distribution you're on. It can be Rocky, CentOS, Fedora. It doesn't really matter. It should work on a Linux distribution. The software is also installed for different kinds of optimized for different CPU generations and GPU generations, and EESSI should detect this as well so that it's running the best binaries on your system. So how does the EESSI experience look like? So the only thing you have to do to get EESSI available if CERN VMFS is installed is run the command on top, which is the source CERN VMFS software.easy.init package. And then actually the file system becomes available. So it sees then what the file system is, but the modules are not yet available on your system. So when you, for instance, module load GROMACS and then run it, it will check your local cache if the software is already there. If it's there, then fine, the software will start running. If it's not there, then it will check the mirror server to get all the software that it needs. It will then be on the local cache. So it might be the case that when you're running the software for the first time that your local cache is still empty, so that it might take a while, but then the second time you use the software, it will be in your local cache, so the software will start running faster. And then we also have a central server on which we install the software, and so this then feeds to the different mirror servers we have throughout the world. And so EESSI provides on-demand streaming of scientific software like music or TV series. So it's kind of a Netflix for software. So now I will do a quick demo on our UGent server. So I started an interactive session earlier. I hope. Yeah, I'm trying to. Is that big enough? No, right? Maybe a little bit too big. And now it's frozen. I know. Oh. Okay. I hope this is this fine? Okay. So at the moment, on the UGent system, modules are always available of the central software stack. So if I do now, you get like a whole list of all the software available. To make sure that nothing gets mixed, we recommend that you run the module purge force purge command at UGent. This is not required, but we just recommend it. It's okay. No, what did I do wrong? Okay, so now we don't have any modules available anymore.
It's to prove that it's live.
Yeah. Okay. And if I do right words, well, then it will be empty. So if I now do the storms like that, and so what it does now is, so what it first did is what. So it found the EESSI repository. So this is the current version of EESSI, but we're also building a newer version at the moment. We're on the Donphan at UGent, which is an Intel Cascade Lake, which it recognizes correctly. It also found an accelerator. In this case, it's also found an accelerator, so it will also set up the path for that, but will not go into GPU software today. And so then it sets up the correct module path where the software is available. So if I now do again module avail TB Lite, then it will become available. So as you can see, here is the path to the software. So as you can see, it's software, cvmfs/software.easy.io, and then the software name. So yeah, okay. So we also have a demo repository with EESSI. So let me quickly. So here we have different kinds of demos for the different software available. We've also now added a script for the TB Lite. So let me first quickly open this. And now we here have the different things. So if I go to the TB Lite directory and print the run script. So as you can see, so the script will load the TB Lite that is available in EESSI right now, and checks the EESSI version that is loaded, and then it will run this script. And this script is just the script that Kenneth showed earlier in the slides, and is the running example that we will be running. So now we can simply run the script. And so now in the background, as I told you earlier, it's getting first the file. So it's, yeah, okay. So it takes a little time. Okay, so now it has run, and as you can see, it run correctly. Do I think different? Okay, you can, as we mentioned, you can also install EESSI yourself on the machine where you have root access. This can be very quick. This is only a setup that takes around 2 minutes. We often do a demo in presentations where we start from a completely empty new cloud environment and have GROMACS running in under 5 minutes. These are the commands that you need to run on a CentOS. On a RHEL-based on a RHEL-based distro, but we also have for others. And in the slides, you can find the link on how to natively install it or using a container. For a container, you don't need root access, only apt container available on the system. So we currently have more than 1,100 software installation per supported CPU target in EESSI. And as you can see, this has been growing since we started building the software in November 2023. At the moment, we have 13 supported CPU targets in x86 and ARM. If you want to get we have 600 different software packages, excluding extensions for Python. So for instance, NumPy and different packages that are like part of a module. They're not counted in this number. So in reality, we have even more than those 1,100 software packages available in EESSI. We have over all the targets and the different software, we now in total have almost 16,000 software installations. So we have Espresso, GROMACS, LAMP, OpenFORM, PyTorch, R, Quantum Espresso. So we already have a lot of stuff that you might need already available there. if you want to get an overview of all the software is available and search it easily, you can visit our documentation. That's the link in the slides, the available software/overview. And there you can easily find the software that is available in EESSI. So as I mentioned, we have 2 versions. So in the 2023.06 version, we have FOSS 2023A and FOSS 2023B stacks, tool chains built. And for 2025.06, we're currently building out the FOSS 2024A and FOSS 2025A tool chains. That is still a work in progress, so we don't have that much software yet in the 2025.06 version. EESSI is also a collaborative. We also wanted EESSI to be a collaborative project where scientists can help us to get their software installed. And so we also have semi-automated the workflow for adding software to EESSI. So on your end, it can be as simple as creating a simple PR in our EESSI software stack, which is most of the time just changing one line in the repository. We will review it then and then submit build jobs to our build clusters. So most of our build clusters, especially for CPU, are in the cloud in Amazon, but we also are using different VSC sites. So we also have a build cluster at UGent and at Surf in the Netherlands for building the GPU stacks. Then when the software is built, we're also running our reframe test suite to check that the software is running for the tests that we have available. Once the installations are all tested and built, then the software will be sent to an S3 bucket. There it will be picked up, and then it will be sent to that central server of CERN VMFS that I mentioned earlier. It will then have another review via the EESSI staging, and once it then is reviewed again, it will be deployed in EESSI and can be in like a couple of minutes. It will be then available on the systems where EESSI is installed. So you can also build software on top of EESSI, which might also be interesting. So if you want to have like a little package on top of PyTorch that isn't available in EESSI, but the PyTorch is, then you can use the PyTorch that's already available in EESSI and build your package on top of it with pip or something like that. We also have modules. We also have some modules to help you with this. So we have the EESSI extend module, which will set up the environment so you can easily build software on top with EESSI build. And to manually install software on top of EESSI, you can use the build-env module. I think we'll later go into the build-env module and how it works. And you can also see documentation. We also do some courses. We also did a webinar in May, I think, on how building software on top of EESSI, which is still available via our YouTube. So you can also visit that if you're interested. So on which system is EESSI already available? So on the VSC systems, it's already available on the tier 2 at UGent and VUB, and also on the tier 1 system in Hortense. You can, of course, also deploy it yourself in tier 1 clouds. It's also EESSI is already also on bigger European systems like the EuroHPC JU systems, including Vega, Carolina, Mare Nostrum 5, Deucalion, and Discoverer, and also some other VSC systems. So we're working together with people at Surf, so it's also available on Snellius, but also University of Stuttgart, Sigma 2, and Normand, and a lot more. You can also visit our documentation to find like a full overview of the systems where we know it's available. And we've also built a note, EESSI notes for the EOS, which is the European Open Science Cloud. All researchers attached to an institution in Europe, they get free tokens to use that cloud. So you can also easily deploy EESSI over there and use that if you want to. Yes, okay. So yeah, as I mentioned a little bit earlier, we had a webinar series in May, June, and yeah, here is a slide on that if you want to revisit those. So if you're interested in any of these topics, you can still revisit the slides and the presentations. Okay, then I will leave it to some.
There is still one question.
Okay. Yeah, we can do questions.
Yeah, there's a question from Peter. Whether Lima is still the best workaround for using EESSI on macOS.
We need to look into this again, but yeah, the documentation is maybe getting a little bit old at the moment.
I just gave him a link on macOS. There's other ways of spinning up Linux containers as well, especially the latest macOS, but we haven't looked into that yet. So there may be better options that we need to explore there. So as long as you can get the Linux version machine, well, either on Windows or on macOS, you can also use EESSI there, but it has to be Linux in some sense. Are there questions in the room here? We're now doing quite well on time, so there is time for questions. Yeah.
So there are multiple versions of EESSI. Can you have those multiple versions available at the same time, so you could search for all modules in one go?
You actually could, yes. We don't have an easy way of doing that. Yeah, but
okay. That's what I.
Yeah.
No,
that's maybe interesting to look into, to do a spider search or even just a veil. Yeah. Also, there you have to be careful which modules you combine loading together.
Sure, but just searching.
Yeah, just searching should be fine. Yeah. Yeah, we don't have an easy way of doing that yet, but we could. Yeah. It's just a matter of adding the same, the correct paths to the module path. So. Yeah.
But you can also online check the models that are available, right?
Yeah. So in the EESSI documentation, there's an overview of it.
I haven't included the 2020 of
only for the 2306 version of EESSI. The others are not exposed in the documentation yet. There's another question. If you don't module purge, will the EESSI modules interact with the VSC modules?
There is a possibility, but it will be very unlikely.
Yeah. So the way we build software in EESSI is very isolated, let's say, with the RPOT linking that we do. That's very technical. So any software that comes from EESSI should be fine. But if you start loading modules that come from EESSI with modules that load from VSC, you may start getting weird things. Especially the VSC ones may not work if EESSI modules are also loaded. So that's why Lara recommended to do the module purge first. And we'll get to that later as well. Generally speaking, you don't want to mix tools from different ecosystems, let's say. So central software stack and EESSI, or modules and Conda, for example. So these kind of combinations are typically a recipe for a bad experience. Yeah. Can you enable the mic just for the, yeah. Pull it down a bit, yeah.
If the EESSI system is available, can end user install it, or it's the one that has the root access that need to install new modules?
No, the modules don't. For the modules, to install the modules, you don't need root access. You just, as I showed in the slides, the
run the source thing.
That you just need the PR. So for that, this one. So I don't know. I'm not sharing.
It depends on what you mean. Yeah. So if EESSI is already available on the system, you just run the source command that sets up your environment, and then you can load modules and run software as a regular user. If you want to build software on top of what's available in EESSI in your own VSC account, you also don't need any special access. You just load the EESSI extend module, for example, and you run an EESSI build command or a pip command or whatever to install things on top. It's only when you want to add software to EESSI itself that you go through this cycle. Then you don't need root access, but there's a way of contributing software to EESSI or proposing to contribute software to EESSI. You only need admin access when you want to make EESSI available system-wide across the whole system. So if you're on a Linux virtual machine, you typically can do sudo install something. That's when you need the root access to give access to EESSI, essentially. But if that's done already on the system that you're on, you don't need any special permissions.
Oops, yes, hello. Maybe a question to the KU Leuven people. Is there something that is on the planning to have installed on the system?
Yeah, we have a test cluster that only admins have access to, and there we rolled it out. And if that goes well, if the tests there go well, then we can make it available, yes. We're still a bit in doubt how it will play out with the modules that we offer centrally. I think at UGent, they also just offer the classic way, let's say, as default, and then allow users to use EESSI instead.
Yeah.
But we're not yet sure how we're going to tackle that. But it's on the planning, that's for sure.
That's also the way we promote EESSI, let's say, as a side software stack. So not really as a replacement for the central software stack that you typically have on the system, but just something you can have on the side. And if you know it's there, you can use it. But it doesn't get in the way of or at least that's the intention, doesn't get in the way of the central software stack. And some sites, well, yeah, what happens if people combine stuff from both sides? That's actually hard to avoid. Then there may be trouble. So yeah, it can raise some questions, of course, for the support people if they want to start supporting EESSI as well next to their own software stack that they have full control over. So, yeah. Well, I mean, we see the adoption growing, and the more sites use it, the better answers we'll have to these questions on mixing stuff or providing tooling around it to provide a better user experience. So there's still stuff that can be done there to make it better. Yeah.
For UGent HPC structure uses, do you currently prefer that we stick to the traditional request that we have new software which is not available, that we submit a request to you for making a model that fits it?
Yeah.
Or a request through the software and then?
That's a good question. I think in Ghent, we feel it's a little bit too early to heavily promote EESSI. This is actually the first training session that we really mention it, but we do hope it can become a more commonly used software stack and maybe even the main software stack, but that's years out. So right now, if you're only interested in using software on the HPC UGent clusters, just do the traditional request. But maybe also mention that you have interest in EESSI or to use the same software on other systems as well. Because once it's installed in our central software stack in Ghent, the step is usually quite small to also install it in EESSI. There's technical details there. It's more difficult to install it in EESSI because of this whole compatibility layer thing and ARM support. And so there are some caveats there. But generally speaking, I hope that in, say, 2 or 3 years, we can actually make EESSI the main software stack and just have stuff on top of that, rather than having two things side by side. It's too early to do that now. But if you're interested, give it a try. If there's software that you would like to see in there, let us know. Just open a ticket or do the EESSI support thing. Or maybe see if you're up for trying it yourself with EESSI Extend. Try to install it first, see if it works. If it does, let us know. And then the steps become smaller and smaller to add something.